Hello. I once heard someone claim that there are about a quadrillion hairs on a human head. And that number seems really high. And so we'd like to estimate the number of hairs on a human head and check that number. Now, sometimes when we do Fermi estimation, we're trying to compare to some other quantity that we're interested in. But sometimes we're just trying to check the accuracy of a fact we've already heard. And that's what we're doing in this case. And because we're just trying to get a feel for whether it's in the ballpark or not, a Fermi estimation is okay because we just want an order of magnitude. A quadrillion is no more precise than that anyway. And so if we can answer that question that accurately, then we'll be satisfied. So we'd like to estimate how many hairs are on a human head. And this is a good example where scaling can be helpful. So notice there's too many hairs on your head to just try to guess the number out of thin air. And so I need to scale that area down to something more manageable. And so in my opinion, a better question to ask is how many hairs in a square centimeter? Now, if you prefer a square inch, that's fine, but a square centimeter is even easier to manage. And I think this is a good place for an interval estimate that we talked about in the last video. And so notice an interval estimate, we're going to ask, well, what's a number that I know the answer is definitely more than that? And then what's an upper bound that I'm positive that the answer is less? And I'm pretty confident that there's more than 10 hairs in a square centimeter on the typical head. And I'm also fairly confident that the number is less than 1,000. And we want to be reasonable with these numbers. We don't want to say like 1 to a billion because that's not helpful. But 10 to 1,000 seems like a reasonable upper and lower bound. And so now we need the geometric mean. So the geometric mean would be the square root of 10 times 1,000, which would be the same thing as the square root of 10 to the fourth, because of 4 zeros. And that would be 100. So we're saying 100 hairs per square centimeter. Now, another way you could have thought about this is maybe how many hairs in a square millimeter. All right, and if we look at a ruler, if we've forgotten, a millimeter isn't very big, so we might even say maybe just 1. So this might be scaling a little too much, but in this case, we might feel like we can estimate this as an alternative. And so we're going to say 1 hair per square millimeter. And of course, if we convert this to square centimeters, there's 100 of those in 1 square centimeter. So that would correspond to 100 hairs in 1 square centimeter. And the nice thing is, that's the same answer as we got before. So although that doesn't prove we did it correctly, it gives us some confidence to move on. So let's do that. So now our question has been reduced to the following. How many square centimeters on a human head? At least on the part that has hair. Now that's another difficult question because we don't know the surface area of a human head. Maybe I could try to Google that. But again, I wouldn't be confident in that answer because everyone's head is different and we're just looking for an average anyway. And besides, we can estimate that with some tools that we have at our disposal. For example, we can assume the head is a sphere. And we can also assume that hair is on half of it. Now, is it exactly a sphere? No. Is hair exactly half? You may think, well, maybe it's closer to 40% or 35%, maybe more. Does it depend whether you have a beard or not? Maybe that changes. But keep in mind, all those things are still within the same order of magnitude. We're not going to radically change our answer if we say 50% versus 40% or something like that. So if we're going to find the surface area of a hemisphere, we need to know the radius of a head. Again, I can do another interval estimate if you prefer. I know it's definitely more than 1 centimeter, and I know it's definitely less than 100 centimeters. Again, we can look at a ruler and see that's clear. In fact, we could even do better than that. We could even probably make that more like 30 or 40 or something. But notice our geometric mean is going to be the square root of 1 times 100, which is 10 centimeters, which is probably not a bad estimate on its own. So you might have been able to come up with that number without using the geometric mean. Notice if you ever have, say, a geometric mean of two numbers where you don't get a perfect square, something like 10 and 100, then it's just going to always be approximately 3 times that number if you're doing pure powers of 10. And you don't have to do only powers of 10. We could have done, say, 20 to 40 or 20 to 90 and taken the square root. So it doesn't have to be powers of 10. Nevertheless, we have a radius, we have a shape, we have what part of the shape we're using, and so now we can find the surface area. So the surface area of a hemisphere would be 4 pi r squared divided by 2. And of course, 4 divided by 2 is 2. Pi, because we only want one significant figure, we can just leave as 3. And then, of course, 10 squared. So that's 6 times 10 squared. So that's 600 square centimeters. And so the number of hairs is 600 times 100. Notice we can use the units. 600 square centimeters times 100 hairs per square centimeter, just to double check that we haven't made a mistake. Square centimeters cancels. We can use scientific notation to write this a little more simply, and we get 6 times 10 to the 4th hairs on a typical head, which is definitely less than 1 quadrillion, right? That's the number we're comparing it to. A quadrillion, remember, would be 10 to the 15th, right? Million is 6, billion is 9, trillion is 12, so quadrillion is 15. So that clearly is an overestimate, that statement that was given. But maybe the person saying this, maybe they didn't mean human head. Maybe they meant the entire body. Would that change our answer if we did the entire body instead? So let's try that out. So what about the human body? All right, and so in this case, again, we need to assume something. Why don't we assume a human is a cylinder? What dimensions are we going to use? We need a radius and a height, or maybe a circumference is a little easier to think about in some ways. So height, I would say probably 6 feet is a reasonable height. Now you may say that's a little high for an average person, and it may be, but remember, we're trying to justify how to get this number up to a quadrillion. So if we estimate a little on the high side for this particular problem, that's okay. So 6 feet. Now we've been doing things in terms of metric, so let's go ahead and convert that to 2 meters or 200 centimeters. Okay, and then the radius, we could think about, well, I know that probably most people have a circumference of 40 inches or less. So see if we can convert that into a radius. So if we're at 40 inches, then that means that I know 2.5 centimeters are in an inch. Technically it's 2.54, but I don't need to get that precise. Notice I could use 2, I could use 3. It's not going to significantly change your answer. But in this case, 2.5 times 40 is actually easy to work out. That's just 100 centimeters as well. So a nice round number. So the lateral surface area of a cylinder, so we're not going to worry about the ends. Maybe we should, but that's not going to dramatically change things. So the lateral surface area of a cylinder is 2 pi RH. So that's going to be 2 times 3 times the radius, which would be 100 divided by 2 pi, 2 times 3, and then times the height, which is 200. Conveniently, the 2 and the 3's cancel, so we're just left with 2 times 10 to the 4th square centimeters. And remember, we had 100 squares per square centimeter, so the number of hairs is equal to 2 times 10 to the 4th square centimeters times 10 squared hairs per square centimeter. Again, we cancel that. And so we get about 2 times 10 to the 6th hairs per body. So about 2 million. And that's certainly quite a bit less than 10 to the 15th. So we're still not right. Or the statement we heard is not right. By the way, if you're curious, you can Google this sort of thing. And here we got, what, about 60,000? That's a little bit on the low side. Most experts would say that number, depending on your hair color and other things, is a little bit more, but it's still within an order of magnitude. Might be closer to, say, 90,000. Maybe the upper bound would be 150. So that would still be within an order of magnitude of our answer. So we haven't made a mistake in that regard either. There might be one more thought. In fact, you might pause the video yourself and say, where did that quadrillion number come from? One can justify it, but how? And it turns out, what if we do the number of human heads on Earth? So now, if you think about it in that way, we know there's approximately, and this we can Google, so this is okay to use well-known information. So we know there's 8 billion people, more or less. So that's 8 times 10 to the 9th. And so if we go back to our original statement about 60,000 hairs on a head, so 8 times 10 to the 9th heads, times 6 times 10 to the 4th hairs per head gives us 6 times 8 is 48. Again, I don't need to sweat the second digit there, so I'm just going to call that 50. So it's going to be approximately 50 times 10 to the, I can add the exponents, so that's 13. Or what is the same thing, 5 times 10 to the 14th hairs, which notice is half of a quadrillion. And so now we have an answer that actually makes sense. This is within an order of magnitude of what was said. And when we recall that our estimate here was probably a little bit on the low side anyway, then it makes sense that yes, there probably is about a quadrillion hairs on heads if you include everyone in the world. And so that's how this Fermi estimation problem works. We'll do another example in the next video, and we'll see you there.